Download this code from codegive.com, link in the description below. Understanding and calculating SHA-512 checksums in Windows command prompt. This tutorial provides a comprehensive guide on calculating SHA-512 checksums of files in Windows using the command prompt. It will cover the basics of cryptographic hashing, the specifics of SHA-512, practical applications, and detailed instructions on how to use the certutil command line utility to generate and verify SHA-512 checksums. 1. Introduction to cryptographic hashing and checksums ****. What is hashing? Cryptographic hashing is a one-way function that takes an input, data of any size, like a file, and produces a fixed size string of characters, called a hash or a checksum. This hash acts as a digital fingerprint of the input data. Key properties of cryptographic hash functions ****. Deterministic ***. The same input will always produce the same hash output. One way, pre-image resistance. It is computationally infeasible to reverse the hash function to find the original input from the hash output. This is crucial for security. Collision resistance ***. It's extremely difficult to find two different inputs that produce the same hash output, collision. While collisions theoretically exist due to the fixed size output, a good hash function makes them practically impossible to find. Avalanche effect ***. A small change in the input data should result in a significant and unpredictable change in the hash output. This makes it very sensitive to even minor alterations. Why use checksums? Checksums are primarily used for data integrity verification to ensure that a file has not been corrupted during transfer, storage, or download. You can calculate the checksum of the original file and compare it to the checksum of the received file. If they match, the data is considered intact. Password storage hashing passwords, using a salt to further complicate the process, before storing them is a security best practice. If a database is compromised, the actual passwords aren't exposed. Data deduplication identifying duplicate files by comparing their checksums. Software integrity verifying that downloaded software hasn't been tampered with by comparing the downloaded file's checksum against the checksum provided by the software developer. Version control tracking changes to files in version control systems like Git often uses hashing. 2. SHA-512, a secure hashing algorithm SHA. Secure hash algorithm SHA is a family of cryptographic hash functions designed by the National Security Agency, NSA. Different versions exist, including SHA-1, SHA-256, and SHA-512. SHA-512 details output size SHA-512 produces a 512-bit hash value, 64 bytes, typically represented as a 128-character hexadecimal string. Security SHA-512 is considered a very secure hash function. Unlike SHA-1, which is now considered broken, SHA-512 is still recommended for security-critical applications. Algorithm it uses a complex series of bitwise operations, modular additions, and rotations on the input data to produce the final hash. A full explanation of the algorithm is beyond the scope of this tutorial, but you can find detailed specifications in the official NIST, National Institute of Standards and Technology, documentation. Speed SHA-512 is generally slower than SHA-256 due to the larger output size and more complex computations. However, on modern hardware, the performance difference is usually negligible for most applications. 3. Using certutil to calculate SHA-512 checksums in Windows command prompt ****. Windows provides a built-in command line utility called certutil that can be used to calculate various cryptographic hashes, including SHA-512. Asterisk syntax asterisk. Asterisk explanation asterisk. Asterisk certutil, the command line utility itself. Asterisk hash file, the option that tells certutil to calculate the hash of the specified file. Asterisk file name, the full path to the file you want to calculate the SHA-512 hash for, example see /users /yourname /documents /mydocument.txt. Enclose the file name in quotes if it contains spaces. Asterisk SHA-512, specifies the hashing algorithm to use. Asterisk example asterisk. Let's say you have a file called my_data.txt located in your downloads directory. To calculate its SHA-512 hash. 1. Open command prompt asterisk press Win+R, type cmd, and press enter. To navigate to the directory, optional you can navigate to the directory containing the file using the cd command, which is helpful if you don't want to type the full path. Replace your name with your actual username. 3. Execute the command asterisk. Or, if you didn't navigate to the directory. 4. Output asterisk. The command will output something similar to this. The long hexadecimal string, example C4A2E2346592F0F1D6C6C8T1E4C7D1A2F7A1B3F1B7D1A2C7C8B2E2D1A2B7D052465, is the SHA-512 hash of your file. 4. Verifying file integrity with SHA-512 checksums ***. Let's say you downloaded a software installation file and the software vendor provides the SHA-512 checksum on their website. Here's how to verify that your downloaded file is genuine and hasn't been tampered with. 1. Calculate the SHA-512 checksum of the downloaded file ***. Use the certutil command as described above to calculate the SHA-512 hash of the downloaded file. 2. Compare the calculated hash with the vendor's hash ***. Carefully compare the hash you calculated with the SHA-512 checksum provided by the software vendor, example on their website or in a text file. It's crucial that you verify the vendor's checksum from a reputable source, not just from the downloaded file itself. 3. Result asterisk. Asterisk. If the checksums match exactly asterisk, the downloaded file is almost certainly the original, untampered file. Asterisk. If the checksums don't match asterisk, the downloaded file has been altered in some way. This could be due to a corrupted download, malware infection, or deliberate tampering. Do not run or install the file. Download it again from a trusted source or contact the software vendor. 5. Example scenario and verification asterisk. 1. Download a file asterisk. Download a small text file, example from a website that offers checksums. For demonstration, let's assume we create a file named example.txt with the content this is a test file. 2. Calculate the SHA-512 hash asterisk. The output will be something like 3. Simulate data corruption, optional to demonstrate the importance of checksums, let's intentionally modify the example.txt file. Open it in a text editor and change test to test. 4. Recalculate the SHA-512 hash, after modification. The new output will be completely different. 5. Verification asterisk. You can clearly see that even a small change, changing test to test, completely alters the SHA-512 hash. This is the avalanche effect in action. If you were expecting the original hash and received this modified hash, you would immediately know that the file had been corrupted. 6. Important considerations and best practices asterisk. Asterisk security of the checksum source. Asterisk always get the expected SHA-512 checksum from a secure and trusted source. If you download the checksum from the same location as the file itself, a malicious actor could have replaced both the file and the checksum. Look for the checksum on the vendor's official website, preferably on an HTTPS secure page. Asterisk copy and paste errors. Asterisk when comparing checksums, be extremely careful when copying and pasting. Even a single incorrect character will cause the comparison to fail. Some tools offer a checksum comparison feature that can automatically compare two checksums for you. Asterisk salting, password hashing. When hashing passwords, always use a random salt for each password. The salt is a unique value that is added to the password before hashing. This makes it much harder for attackers to use pre-computed rainbow tables or other techniques to crack the passwords. Certutil is not suitable for password hashing because it doesn't support salting or key stretching. Use dedicated password hashing libraries or functions for that purpose. Asterisk choosing the right hash algorithm. Asterisk SHA-512 is generally a good choice for most applications requiring a high level of security. However, for some very specific use cases, example resource-constrained devices, other algorithms like SHA-256 might be preferable. Consult with security experts if you are unsure which hash algorithm is appropriate for your application. 7. Batch processing with certutil****. You can use certutil in batch scripts to calculate SHA-512 checksums for multiple files at once. Explanation. At echo off, suppresses command echoing to the console. For %% in, see \path \to \files\star.txt, do, iterates through all files with the .text extension in the specified directory. Replace C \path \to \files\star.txt with the actual path and file pattern. The %a variable represents the current file being processed. Echo processing file, %a, prints the name of the file being processed. Certutil hash file %a SHA-512, calculates the SHA-512 hash of the current file. Echo, prints a blank line for better readability. Pause, pauses the script execution so you can see the output before the command window closes. Save this code in a .bat file, example calculate_hashes.bat, and double-click it to run. The script will calculate and display the SHA-512 checksums for all the .text files in the specified directory. You can modify the file pattern, star.txt, to process different file types. 8. Limitations of certutil****. No built-in verification. Certutil calculates the hash but doesn't have a built-in option to directly compare it against a known value. You'll need to manually compare the output. Basic functionality. It's primarily a certificate management tool that can also be used for basic hashing. For more advanced features, you might consider using PowerShell or a dedicated hashing tool. No password hashing best practices. As mentioned before, it is not suitable for password hashing, so don't use it for that. 9. Alternative tools, beyond certutil. While certutil is convenient for simple SHA-512 calculations, other tools offer more advanced features. PowerShell. PowerShell provides cmdlets like getFileHash that are powerful and versatile for hashing files. PowerShell offers scripting capabilities for more complex checksum management tasks. #HashCheck**, a free and open source Windows shell extension that adds checksum calculation and verification functionality to the Windows Explorer context menu. This is a very user-friendly option. *MD5 and Checksum utility *, another free and easy-to-use graphical utility for calculating and verifying checksums. *Third-party hashing libraries, for developers, various libraries in languages like Python, Java, C, etc., provide robust and flexible hashing functionalities. 10. Conclusion ***. SHA-512 is a powerful and widely used cryptographic hash algorithm for verifying data integrity. Using the certutil command line utility in Windows, you can easily calculate SHA-512 checksums of files and verify their authenticity. Remember to always obtain checksums from trusted sources and carefully compare them to ensure your data hasn't been compromised. While certutil offers a basic solution, exploring PowerShell or dedicated hashing tools can provide more advanced features for complex scenarios. By understanding the concepts of cryptographic hashing and utilizing the appropriate tools, you can protect your data and ensure its integrity. Remember to prioritize security best practices, especially when dealing with sensitive information.